Welcome to qnawire.
This is the answer to Chapter 20, problem number 34 from the McMurray Organic Chemistry textbook. This problem is sort of the opposite of the problem before it, number 33, in that in number 33, we were asked to start from butanoic acid and convert that into 5 different things. But here in number 34, we are asked to start from 5 different starting materials and convert each of them into butanoic acid. So looking at A, we have 1 butanol here, and we want to get to butanoic acid. And so we can do this simply by using a strong oxidizing agent. So chromium trioxide is a good one. And then we would do an acidic workup there. And that is going to get us to our butanoic acid. Okay, and then for B and C, we're actually going to try to get to 1 butanol, and then again use chromium trioxide to oxidize that to butanoic acid. Okay, so for B, as I said, we need to start by getting from 1 bromobutane, to 1 butanol. And so we can do that just by using sodium hydroxide. And so that is going to get us to 1 butanol. And then again, just like in A, chromium trioxide and some acid. Gets us to butanoic acid. Okay, and then for C, we will start again by getting to 1 butanol. And to do that in C, we need to do an anti-Markovnikov hydration. So we need to add the elements of water in an anti-Markovnikov fashion. And so the way to do that is to use a boron reagent. So BH3 works. And we always write that we include, that we do that in THF. And then we need to follow that with hydrogen peroxide and some base. So H2O2, and then just hydroxide ion is usually how that's written. And so that is, again, going to get us to 1 butanol. And then from there, just as in A and B, chromium trioxide and acid. Okay. So that's A, B, and C. So then here in D, we are starting from 1 bromopropane. So we need to not only get from the alkyl halide to the carboxylic acid, we actually also need to add a carbon. And so there are 2 ways that we could do this. We could follow a Grignard pathway and use carbon dioxide, or we could use sodium cyanide and then hydrolyze that nitrile that we make. And so that's what I'm going to do. So I'm going to use sodium cyanide, as I said, NaCN, and then follow that with some acid. And that is going to get us to where we need to be. So we've added a carbon, and we've gotten to the carboxylic acid here. All right. And then so lastly, we need to go from 4-octene to butanoic acid. And so basically, when we look at 4-octene, there are 4 carbons on each side of this double bond. So we need to cleave this double bond in such a way that we end up with carboxylic acid. And so we could do this via ozonalysis. So we could do, ozone followed by an oxidative workup. or I think the answer that the book prefers is going to be potassium permanganate. So KMnO4. And then again, some acid in there. And so that is going to get us 2 equivalents of butanoic acid. Okay, and so that's part E, and that is the answer to chapter 20, problem number 34.